A massive cargo ship has spent 30 years traveling the world's ocean routes carrying containers across every major shipping lane. The vessel has transported millions of containers and generated significant revenue for its owner over its operational lifetime. However, ships do not operate forever regardless of maintenance investments. Eventually, every vessel reaches the end of its operational life and becomes economically unviable to maintain. At this point, the ship faces either expensive continued maintenance or formal decommissioning. Most ship owners choose decommissioning because maintaining aging vessels becomes economically unsustainable and unprofitable. The ship enters a final phase of its complete life cycle. Understanding how ships get recycled and decommissioned reveals complex environmental, economic, and human dimensions of maritime industries worldwide. Today we're exploring ship-breaking operations, the valuable materials recovered, the significant environmental hazards involved, critical worker safety concerns, and the future of sustainable ship recycling practices developing globally. A ship scheduled for decommissioning travels to a specialized ship-breaking yard. Ship-breaking yards are located primarily in South Asia, particularly in Bangladesh, India, and Pakistan where most capacity exists. These countries have established major industries specifically focused on systematically dismantling end-of-life vessels. The ship-breaking industry employs tens of thousands of workers across multiple yards. The industry recovers valuable materials and metals from decommissioned ships for resale. However, the environmental and safety standards in many yards remain quite low compared to developed nations. Workers face significant occupational hazards during the entire dismantling and cutting operations. The ship-breaking process is fundamentally labor-intensive rather than capital-intensive. Developing nations dominate this industry because labor costs remain substantially lower than in developed countries. Ship-breaking yards in Asia process approximately 80% of globally decommissioned vessels annually. A typical large container ship may generate revenues of 1,000 to 5,000 tons of recyclable steel. The steel is sold to steel mills and smelters and reprocessed into new commercial products. Copper wiring extracted from the ship commands high prices in international metal markets. Other valuable materials including aluminium, brass, and bronze are recovered systematically and sold separately. The ship-breaking process begins when the aging vessel arrives at the designated yard location. The ship is secured firmly to the beaching location using heavy anchors and cables. Workers then begin systematic dismantling starting from the superstructure components. The mast, bridge structure, funnels, and ventilation systems are cut down carefully. These upper components contain valuable copper wiring and aluminium that are separated and sold to metal dealers. Workers use cutting torches, plasma cutters, and manual hand tools to disassemble equipment and structures methodically. The process exposes workers to numerous serious environmental hazards. Asbestos insulation was extensively used in ships constructed before the 1980s as a standard practice. Asbestos fibers cause mesothelioma and lung cancer when inhaled over extended periods. Many Asian ship-breaking yards do not implement proper asbestos removal procedures and protections. Workers inhale asbestos fibers without adequate respiratory protection or safety equipment. Paint containing lead and other heavy metals is scraped from surfaces and discarded improperly. Lead exposure causes neurological damage, particularly in developing children and pregnant women. Mercury switches and other hazardous components are sometimes improperly discarded into the environment. Polychlorinated biphenyls stored in electrical equipment contaminate soil and groundwater severely. The hull itself represents the largest material component of the entire ship by mass and volume. After the superstructure and internal equipment are completely removed, cutting crews begin methodically sectioning the hull. The hull is cut into large sections using gas-cutting torches and advanced cutting equipment. The cutting process generates intense heat and sparks that create significant fire hazards. Workers operate cutting torches in confined spaces with severely limited ventilation and air circulation. Toxic gases are produced during extended cutting operations, including carbon monoxide and hydrogen sulfide. Many workers lack proper respirators or use completely inadequate protective equipment. The large hull sections are then cut into smaller pieces suitable for steel mills and smelting facilities. The steel sections are transported by truck or transported to industrial smelting and reprocessing facilities. A typical large container ship yields approximately 8,000 to 12,000 tons of recyclable steel. The steel is melted and reformed into new commercial products including construction materials. The recycled steel has lower processing costs than virgin steel produced from raw ore. However, contaminated steel may contain harmful residual elements from original construction. Lead and heavy metals concentrated in hull paint can contaminate recycled steel products permanently. The quality and safety of recycled steel depends entirely on proper cleaning and processing procedures. Environmental contamination in ship-breaking yards creates lasting damage to local ecosystems and communities. Heavy metals accumulate in soil surrounding breaking yards, affecting local agriculture. Rainwater carries contaminated sediment into coastal waters and groundwater aquifers. Fish and other marine organisms accumulate toxic metals through bioaccumulation processes. Local communities consuming contaminated seafood ingest dangerous levels of toxic metals, causing illnesses. Groundwater contamination affects drinking water supplies for nearby residents. The environmental cleanup required after a yard closes involves decades of effort. Some yards operate with minimal environmental controls and protections. Oil residues in cargo tanks spill into the environment, contaminating beaches. Heavy fuel oil contaminates beaches and waterways and persists for many years. Environmental organizations have documented severe ecological damage from ship-breaking operations. Protective equipment and proper waste management dramatically increase operational costs. Many yard operators view environmental measures as unnecessary expenses, reducing profits. The lack of enforcement in developing nations permits continued environmental degradation. The long-term health costs to communities exceed short-term operational savings. Worker safety in ship-breaking yards ranks among the most dangerous occupations globally. Workers face constant hazards including exposure to hazardous materials, falls from heights, and serious fires. Workers die in ship-breaking yard accidents at substantially higher rates than in other maritime industries. Proper safety equipment including harnesses, helmets, and respirators is often unavailable or not required by management. Workers frequently work in confined spaces with limited escape routes in emergencies. Oxygen-depleted atmospheres in ship compartments cause sudden loss of consciousness and death. Workers have drowned in partially flooded compartments while attempting salvage operations. Burns from cutting torches and explosions from flammable materials cause severe injuries and deaths. Medical facilities near breaking yards are typically inadequate to treat serious injuries. Infection rates from untreated wounds are high in developing yard communities. Many workers lack compensation for workplace injuries or occupational illnesses. International labor organizations have documented persistent violations of worker safety standards. The cost of proper safety measures and medical care further increases operational expenses. Without regulatory enforcement, most yards prioritize rapid dismantling over worker safety and health. International efforts to improve ship-breaking practices have achieved limited success in transforming the industry. The Hong Kong International Convention for Safe and Environmentally Sound Ship Recycling was adopted in 2009. The convention establishes comprehensive standards for ship-breaking including hazard identification and worker safety. However, many developing nations have not ratified the convention formally. Even nations that ratify the convention often lack adequate enforcement capacity and resources. Ship owners sometimes avoid the convention by selling vessels to yards in non-signatory nations entirely. Proper ship recycling following convention standards increases costs significantly. Some ship owners sell vessels to non-compliant yards to maximize financial returns. Environmental and labor organizations continue advocating for stronger international regulations. Auditing and certification programs have been established to identify compliant recycling yards. However, compliance verification remains inconsistent and incomplete. Financial incentives for compliant yards remain inadequate to drive widespread industry transformation. The profitability of non-compliant operations continues to attract new yards and operators. The future of sustainable ship recycling depends on technological advancement and strict regulatory frameworks. Automated dismantling equipment could replace dangerous manual cutting and handling processes. Robotic systems could handle cutting and material handling with fewer human workers. Advanced environmental controls could minimize contamination and protect local ecosystems. Hazardous material removal could occur before major cutting begins systematically. Pre-cleaning procedures could remove oils, pollutants, and hazardous substances systematically. Higher labor costs in developed countries create barriers to establishing compliant yards. Economic pressures continue driving operations toward yards with the lowest operational costs. Ship owners and buyers resist higher decommissioning costs that reduce end-of-life vessel value. Sustainability requires that consumers accept higher costs throughout the shipping supply chain. International enforcement mechanisms must ensure compliance across all maritime nations. Carbon footprint considerations for ship recycling are increasingly important. Recycling steel produces less environmental impact than mining virgin ore. However, contaminated recycling processes negate these environmental benefits. Future regulations may mandate ship design features facilitating safer dismantling. Designing ships for deconstruction could reduce hazardous material exposure during recycling. Understanding how ships get recycled and decommissioned reveals complex environmental, economic, and human challenges. Ship-breaking yards recover valuable materials from end-of-life vessels, providing economic benefit to developing nations. However, current practices expose workers to severe hazards and contaminate local environments permanently. The industry demonstrates how cost pressures can override safety and environmental concerns completely. International standards exist but lack consistent enforcement and compliance mechanisms. Worker safety conditions remain unconscionable in many yards across developing nations. Environmental contamination persists for decades after yard closures. Future sustainability requires technological innovation and regulatory transformation globally. Developed nations must actively support compliant yards in developing countries. Consumer awareness of hidden environmental and human costs in maritime operations is increasing. Ship recycling represents the final chapter in maritime vessels' life cycles. The chapter should be written with respect for worker safety and environmental protection. If you're concerned about the environmental and human costs hidden in global shipping operations and want to understand the true complete life cycle of maritime vessels from construction through final recycling, subscribe to the channel now. We explore complex systems in maritime industries, including the environmental and human impacts of shipping worldwide. Understanding ship recycling practices reveals broader sustainability challenges in global maritime commerce. Your subscription supports content exploring maritime industries from multiple perspectives and viewpoints. Thank you for watching and for your interest in understanding how ships get recycled and decommissioned and the complete life cycle of maritime vessels throughout history.